Venus is often called Earth's twin, but its story couldn't be more different. Shrouded in thick clouds and wrapped in relentless heat, Venus hides secrets that continue to baffle scientists. One of the biggest mysteries? Its lack of giant impact craters. On rocky bodies like Mercury, Mars, or even our Moon, we see massive scars from ancient asteroid impacts, clear evidence of the solar system's violent past. Yet, on Venus, such craters are strangely scarce, especially the larger ones. This oddity has puzzled planetary scientists for years. Why does Venus, a planet so similar in size and composition to Earth, have so few craters? Recently, a team of scientists came up with a fascinating possibility: these missing craters might not be missing at all. They might have been hiding in plain sight, camouflaged as unusual landforms called tesserae. These tesserae are vast, rugged regions on Venus' surface, often spanning areas as large as continents. They appear wrinkled and ridged, resembling sheets of corrugated metal, and scientists have long wondered what processes could have formed these strange patterns. Now, there's a hypothesis that some of these tesserae may actually be ancient impact sites. So, why might Venus's craters look so different? The answer could lie in Venus's intense geological activity. The planet has experienced periods of extreme volcanism, events so powerful that they've resurfaced much of the planet, covering up evidence of older impacts. Venus's unique environment might have transformed what we think of as traditional craters into the tesserae we see today. In other words, we may have been looking for the wrong thing. Instead of deep, clear craters, these impacts may have created flattened, ridged plateaus due to Venus's unique conditions. If this theory is true, it would reshape our understanding of Venus's history. It could reveal a record of impacts dating back billions of years, offering an unprecedented glimpse into the past of our neighboring planet. Join us as we dive deeper into this mystery and uncover how Venus's hidden impact craters could rewrite the story of the solar system's rocky worlds. The tesserae of Venus are unlike anything we see on Earth or anywhere else in the solar system. These expansive, rugged terrains, some as large as entire continents, are among the most mysterious features on Venus's surface. They look chaotic and broken, covered in wrinkled ridges and jagged lines, as though the surface had been crumpled and stretched. For years, scientists puzzled over how these formations could have come to be. What geological forces were powerful enough to create these warped, alien landscapes? To understand the tesserae, we have to consider Venus's unique geology and violent past. Unlike Earth, where plate tectonics drive the reshaping of continents over millions of years, Venus operates differently. While our planet has a crust that breaks apart and shifts over time, Venus has a thick, rigid crust, or lithosphere, that behaves more like a single, massive shell. This means that tectonic processes unfold in ways that are far more intense and less forgiving than what we experience here. And when Venus's internal heat finally forces its way through this unyielding shell, the results are dramatic episodes of global volcanism that can entirely erase ancient features, creating a reset of the planet's surface. The tesserae may be relics of this ancient and destructive cycle. Billions of years ago, when Venus's crust was much thinner, these vast, crumpled landscapes could have formed in response to powerful geological forces, possibly impacts from asteroids that tore through the thin lithosphere and unleashed waves of molten lava from beneath. With a lithosphere only around 10 kilometers thick, compared to the 70 kilometers it is today, such impacts would have been devastating, creating wounds in the crust. The aftermath? Lava flooding into these massive craters, pooling, cooling, and eventually hardening into the complex, ridge-like structures we now call tesserae. Over time, the denser materials would settle deeper into Venus's mantle, causing these plateaus to sink back toward the surface, compressing and wrinkling under the planet's weight. If this theory is correct, then the tesserae aren't just geological oddities, they are ancient impact sites, preserved by the unique geological makeup of Venus. This changes how we understand craters and impacts, forcing us to rethink how the violent events that shaped rocky planets manifest under extreme conditions. The Hostbad tessera is a prime example of Venus's hidden history. Spanning roughly 1,500 kilometers, it's a strikingly vast region that could be one of the oldest, most significant impact sites on Venus. To uncover its origins, scientists turned to detailed radar imaging and advanced modeling, tools that allow them to peer through Venus's dense clouds and analyze its surface. Through these methods, researchers found clues that paint a picture of a dramatic impact event, one that likely occurred billions of years ago when Venus's crust was far thinner than it is today. The modeling reveals that, in its early history, Venus had a lithosphere only about 10 kilometers thick, a delicate shell compared to the robust 70-kilometer crust it boasts now. At this thinner stage, a large asteroid could have easily punched through to the molten mantle below. The impact would have left a massive depression, a scar in the planet's surface, where molten rock from the mantle flooded upward, filling the crater and forming what we now recognize as the Hostbad tesserae. But the story doesn't end there. Over time, the hot, flowing mantle beneath Hostbad would have continued to shift and move, displacing the lighter residuum that had formed this plateau. Eventually, this floating material would be swept away, allowing Hostbad to settle back into the surface, leaving behind a distinctive, rugged topography as a testament to its violent past. The unique features of Hostbad, with its layered ridges and complex structure, hint at the immense forces that shaped it. Unlike traditional craters, this impact site was molded and redefined by Venus's geological processes, taking on a form that's almost unrecognizable compared to the craters we see elsewhere in the solar system. Hostbad offers a rare window into Venus's early days, preserved only because it managed to avoid the planet's more recent volcanic resurfacing events. This ancient landscape holds the key to understanding the violent collisions that shaped not just Venus, but all the rocky planets in our solar system. The Hostbad tesserae's secrets go deeper than a single impact. Scientists noticed something unusual: concentric rings rippling out from its center, a feature rarely seen in impact craters on Venus. These rings hint at an intriguing possibility: Hostbad might have experienced not just one, but two distinct impacts. This idea is bolstered by comparisons with formations found on the icy moons of Jupiter, where multiple impacts create similar concentric patterns in a different context. On Jupiter's moons, these rings occur when an object strikes a surface that has a hard crust and a softer layer below, like ice over an ocean. When the impact energy hits, the shock waves ripple outwards, forming frozen rings. In the case of Hostbad, though, it's not ice and water, it's the interplay of hard, cooled crust with a molten pool of lava lying just beneath. When the first impact hit, it broke through the thin lithosphere and flooded the area with lava. Then, a second asteroid, estimated to be about 70 kilometers in diameter, struck this already weakened, lava-filled basin, creating a new set of ripples preserved as concentric rings around the impact zone. This double impact scenario is rare but not entirely unheard of. Across the solar system, scientists have identified similar cases, including a few on Earth where multiple impacts created overlapping structures. However, Hostbad stands out due to its scale and the unique conditions on Venus that helped to shape it. The planet's extreme heat and pressure would have hardened the lava quickly after the impacts, preserving these rare rings as a geological record of one of the most intense periods in Venus's history. These rippling rings provide clues not only to Venus's past but also to the broader dynamics of planetary impacts. They showcase how environmental factors, like a planet's crust thickness, internal heat, and surface materials, play a crucial role in how impact features evolve. On Venus, where the climate and geology are unlike anywhere else in the solar system, the remnants of impacts don't form deep, towering craters. Instead, they become sprawling tesserae, almost unrecognizable as craters but holding profound insights into the planet's violent past. This discovery redefines what we might look for in future Venusian exploration. It challenges our assumptions about what an impact crater should look like, especially on planets with extreme geological and environmental conditions. Hostbad's rings open up new possibilities. What other secrets might Venus be hiding in plain sight, masked by unique surface formations? Hostbad and the tesserae of Venus invite us to reconsider what we think we know about planetary geology and the forces that shape worlds. The evidence of possible double impacts and the transformation of craters into tesserae under extreme conditions reveal a portrait of Venus as a planet that endured intense, volatile periods early in its history. But unlike Earth, which retains an accessible record of its geological past through continents, mountain ranges, and oceans, Venus's surface has been effectively reset numerous times by volcanic resurfacing. These tesserae might be the only windows left into its ancient past, offering glimpses of the collisions that could have been instrumental in shaping the planet we see today. What we are learning from Venus challenges us to look beyond traditional definitions of impact craters. Instead of searching for deep, well-defined holes, we are now exploring the idea that the scars of Venus's past might lie hidden in the vast, plateau-like tesserae regions. And as we discover more about these features, we may also gain insight into similar geological processes that could exist on exoplanets orbiting distant stars. The more we understand about how Venus's surface has recorded its history, the better prepared we are to interpret landscapes on other worlds with atmospheres and geological activity that differ vastly from Earth's. This newfound understanding of Venus could spark a shift in how planetary scientists approach the search for ancient impacts and geological history on other rocky planets. Hostbad and the tesserae serve as compelling evidence that planetary surfaces might record the past in ways we haven't fully understood, shaped by forces unique to each world. This insight could guide future missions to Venus, where more sophisticated instruments might one day explore the tesserae directly, peeling back the layers of history embedded in these remarkable formations. As we continue to search for answers, Hostbad reminds us that even the familiar can hide extraordinary mysteries, waiting for the right perspective to bring them into view. Join us on this journey of discovery as we dive into the unexplored depths of our solar system and beyond, uncovering the stories that lie beneath the surface of distant worlds. By subscribing and following along, you're not just supporting a channel but joining a quest to unlock the secrets of our universe, one world at a time.